Welcome back. In this fourth video of our Generating Reports with Python series, we'll learn how to directly generate PDF reports using Python. Hi everyone, I'm Justin. Welcome to Just Into Data, where data science materials are shared and made simpler for you. As you may recall, in the first video, we've created some content for reporting. Two data frames, SP500 History and SP500 History Summary, as well as a line chart that was saved as chart.png file on the local computer. Let's use them to generate a PDF report. If you prefer to generate HTML reports first and then convert it to a PDF document, please watch our previous video in the series. In this video, we'll show a method to generate PDF reports directly in Python. Before generating any reports, it's always a good idea to think about how you want the report to look. So let's take a look at the final PDF document we will build. Here it is. We'll have a title of Daily SP500 Prices Report, followed by the line chart and two tables of data. With this final report in mind, let's head to JupyterLab to generate it. Like before, I already copied the code to save us time. We'll use this Python package called FPDF. I would strongly suggest you to read FPDF's minimal example in its official tutorial. It's short, but you'll learn the very basics of how to construct a PDF page using the FPDF package. I'll put a link in the description. Alright, now let's go back to the notebook to read our code. Here's the main code to create the PDF report using FPDF. First, we set up the basic setting for a PDF page with FPDF. Create a FPDF object with default values so that the page will be A4 and portrait. Then add a page, and also set a font of the entire page to Arial Bold 16. You can change these settings, but I'll just keep them simple. Then we need to lay out each item we want to see in the report on this page. By default, we start adding content around here, the upper left corner, and of 1 centimeter from the borders. The first thing we want would be a title of the report. In an FPDF document, we use cell, a rectangular area to hold text. So this line of code is creating a cell with dimensions of 40 times 10, I think in the unit of millimeters, with text, Daily S&P 500 Prices Report. The text in this cell is Arial Bold 16, as we set up earlier. Then, after the title, we want to add a few lines before adding other content. That's why we have the line break with a height of 20. Below the break, we'll add the image as a chart.png file we've saved on our computer, followed by more line breaks. Next, we want to show the table of the historical data of S&P 500. The data frame SP500 History holds the historical data we want to display. We'll need to first change it a little bit. Let's try copying these few lines of code outside to see what transformation we are doing to the data frame. So let's run it, and then print out the transformed version of SP500 History PDF. As you can see, we've reset SP500 History index of date as a column, and changed the date column to data type of string, and also selected all the columns with numbers as numeric calls, and then rounded their values to 2 decimal places. This is necessary because the FPDF package doesn't have a component to nicely display a pandas data frame. So we need to transform it to look nice like this before displaying it. Now going back to the main code, here comes the real challenge. The basic unit to display text with FPDF is cell. We must loop through each element within this data frame or table to display them within each cell on the PDF page. This is a lot of work, so we've written a function, outputDF to PDF. It takes in a data frame, which is the last 3 records in the SP500 History PDF data frame here, and add it to the FPDF object called PDF we've set up earlier. Let's take a look at what's going on in this function. If we scroll up, here's the function. In summary, this function loops through the columns and rows of a data frame to display each element on cells in the PDF. We'll go through this line by line. First, we set two variables, table cell width and table cell height, as 25 and 6. This will be the width and height of the cells of the output table. Then we want the font within the table to be different from other text on the PDF. So we're setting the font again as Arial, bold, and 8. As you might recall, we've set the text in the document to be Arial bold 16. So the text in the table has a smaller size of 8 versus 16. Then it's time to loop over to print the columns of the table. Calls holds all the column names of the data frame. For call in calls, we write on a cell with the width and height defined earlier. The text of the call, which is a column name, a line as center, and a border of 1, which means a framed border. After printing out each column name on the same line, we can use a line break to go to the next line. So that's what this line break is for. Then we'll set the font again. We want the data within the table to be different looking from the column names as well. We're still making it Arial, regular so no more bold, of size of 10. Then we loop over the data frame to print each data in the table. For row, in data frame's iter tuples, the iter tuples can be iterated over data frame rows as named tuples. For details, you can research more about the named tuples, but it's not mandatory here. Then looping through each column name, this value will be a string of the specific data points. We use this function, getAttr, of row and call to access the data. Then we are writing such value to a cell that's center aligned and with border. Similarly, after writing all the data on one line, we need to break onto the next line to write the next row of data. And that's it. So again, this function takes in a data frame, loops through its column names and data, and prints each of them in a structure of table in a FPDF object. Let's run it. Now back to our main code below. We are using this function, outputDF to PDF, to add the last 3 rows of historical data to our PDF object, which is this table here. Let's zoom in on it. You can see these are the column names, which are bold and different size as the data below. The data shown here are the last 3 rows of the historical data. Now back to the main code. The table is followed by some line breaks. Then we display the table of historical summary statistics. It is the same process as a previous table, so we first transform it, reset index, round all numbers, and then use a custom-defined function to print it to cells on PDF. At the end, we use this line of code to output the PDF file. Let's run this. Now if we go to the working directory, we can see this new PDF document added. If we open it, there's a PDF document we've designed. The title, some line breaks, an image, and 2 tables of data. That's it. There's certainly more customization you can do to generate PDFs with FPDF, but you've got the basics. This is also the last video in the Generating Reports with Python series. In summary, you've learned examples of using Python to generate reports as Excel, HTML with template, converted to PDF, and PDF directly. Each of them is good for different scenarios. If you want an interactive web-based report or dashboard, we highly recommend Plotly Dash. You can either take our comprehensive introductory course, Python Interactive Dashboards with Plotly Dash, or check out our YouTube video of quick tutorial. I'll put links to both in the description. Now that you've learned how to generate reports in Python, we can also send emails to share these reports using Python. We'll show you how to do that in another video. Stay tuned. Did you learn something new in this video? If so, make sure to subscribe to our YouTube channel. Just click the subscribe button below this video right now. If you're interested in more data science tutorials and courses, please head over to our website, justintodata.com. Thank you, and see you in the next video.